Hi students, so welcome to the session 2 of module 3. So here in this session I'm going to discuss about logistic regression. So in the previous session we were talking about linear regression and multiple linear regression. So the next type of regression is logistic regression. So linear regression predicts the numerical response, but it is not suitable for predicting the categorical variables. So logistic regression, I have mentioned already that it is not actually a regression problem, it is a classification problem, because here the dependent variable will be categorical in nature. So whenever the dependent variable is categorical, then it is a classification problem, and logistic regression is suitable for binary classification problems. That is, there will be only two classes for classifying. So here are some example scenarios where we can apply logistic regression to check whether a mail is spam or not. So here the answer will be either yes or no. That is, it will be either a spam mail, yes, or it is not a spam mail, so that is no. So the categorical dependent variable, it is of a binary response of yes or no. Only two classes are there for classification. So that is why we can apply logistic regression here. Now next example, if the student should be admitted or not is based on entrance examination marks. So based on the marks, we have to decide whether student will be admitted or not. So again there are two classes. Now next one is the student being pass or fail is based on the marks secured. Based on the marks, we have to predict whether the student will get a pass or a fail. Again there are two classes. So that is the thing that we have to keep in mind whenever the dependent variable is categorical or it is a binary classification problem. There we can apply logistic regression. Now how does the logistic regression algorithm works? So this is again a recap of linear regression. So here in this example, an organization wants to determine an employee's salary increase based on their performance. So for this purpose, linear regression algorithm will help them to decide that, and we have plotted a regression line by considering the employee's performance as the independent variable and the salary increase as the dependent variable. So employee rating, that is the employee's performance, so that is given in x-axis, and the hike in salary is given over y-axis. Now suppose employee rating is 1, we can draw like this a dotted line, we can draw to this line, and we can check whether, okay, here if it is 1, then there will be a 5% salary hike. If it is 2, it is approximately 10% salary hike, like that. Now, what if the organization wants to know whether an employee would get a promotion or not based on their performance? So, in linear regression, we were predicting a numerical value, that is the salary hike, how much hike will be there in the salary. But now there is a slight change in the requirement, that is we need to predict whether the employee will get promotion or not, either yes or no, based on their performance. So again employee rating will be in the x-axis, and in the y-axis we are going to predict whether employee will be given a promotion or not. What is the chance of promotion? So here the linear graph will not be suitable. So that is why we are going to clip the line at 0 and 1 and convert that straight line into a sigmoidal curve or S curve. The shape of this curve is S, and it is clipped at 0 and 1. So this is how the curve will look like in case of a logistic regression. And here if the employee rating is 1, I can clearly say that the probability is 0. That means he is not going to get promoted. Or if the employee rating is 5, here also I can directly say that the probability is 1. So definitely he will get promoted. And what if this employee rating is 2, 3 or 4? Suppose if it is 4. In that case, it is going to be 0.75. So what is the chance that the employee will get promoted or not? Or if it is 3, it will be somewhat over here, that is 0.5. It is the probability of getting promotion. So logistic regression is a probabilistic model. So whatever value we are going to generate over here, that will be a probability value, always lying between 0 and 1. If it is 0, in this case, the employee is not going to get promoted. But if it is 1, he will be getting promoted. Now, what is the purpose of these values in between 0 and 1? How we can decide? if an employee is getting promoted or not, if the probability value comes any of these. So for that we need to assign a threshold value. Suppose here I am saying that threshold is zero point 0.5. So only if the probability that we are getting is above 0.5, then the employee will be promoted, otherwise he will not be promoted. So that is a condition that we will keep in logistic regression. There will be a threshold value. Now we can see what all are the equations, or what is the algorithm for logistic regression. So to understand logistic regression, let's go over the odds of success. Odds of success you might have learned in probability in mathematics. So odds of theta is equal to probability of an event happening divided by probability of an event not happening. Suppose P is the event. So probability of event happening is P divided by event not happening is 1 minus P. So values of odds ranges from 0 to infinity, and the probability values, as we all know, it is always lying between 0 to 1. Now here we will consider the equation for the straight line. Y is equal to beta 0 plus beta 1 x. So beta 1 is the slope and beta 0 is the y-intercept. So just I have plotted that particular line over here. Now we need to predict the odds of success. That is, logistic regression actually predicts the probability of a particular event that is going to happen, whether it is going to happen or not. What is the probability for that? So again, we are going to take log on the odds formula. So this was the odds formula, p of x by 1 minus p of x. I have taken log on it and equated it with the straight line equation beta 0 plus beta 1 x. Now here I am going to exponentiate both the sides. So when I am taking exponentiation, it will be converted into natural logarithms e raised to ln of p of x by 1 minus p of x equal to e raised to beta 0 plus beta 1 x. So we know that e raised to ln of x is same as x. So this we can rewrite as p of x by 1 minus p of x equal to e raised to beta 0 plus beta 1 x. Now let y is equal to e raised to beta 0 plus beta 1 x. Then what will happen? This p of x by 1 minus p of x will be equal to y. And we can write it like this. P of x is equal to, taking this denominator to the RHS, y into 1 minus p of x, opening the brackets, y minus y into p of x, then bringing it to the left side. What will be the value of p of x? It will be y by 1 plus y. So here I have taken p of x common outside, 1 plus y, and p of x is equal to y by 1 plus y. Now resubstituting this y value back to e raised to beta 0 plus beta 1 x, it will be like this: e raised to beta 0 plus beta 1 x divided by 1 plus e raised to beta 0 plus beta 1 x. So the equation of the sigmoidal function will be this. How we got this? We will be dividing the numerator and denominator with eta raised to beta 0 plus beta 1 x. So this numerator will be 1 divided by 1 by e raised to beta 0 plus beta 1 x plus 1. So that we are going to write it as 1 plus e raised to minus of beta 0 plus beta 1 x. So this is the equation for sigmoidal function. And the sigmoidal curve, that this is the previous curve that we have seen in the previous slide for that employee rating and probability of getting a promotion. Now here I have mentioned an example. A student data set has entrance marks based on the historic data of those who are selected or not selected. Based on logistic regression, the values of learned parameters are beta 0 is 1 and beta 1 is 8. So these are the regression coefficients, and assuming the marks of x is equal to 60, we have to compute the resultant class, whether that student will be selected or not. And threshold is also given in the question, that is 0.5. So just, it is very simple, just write down the equation for the sigmoidal function, that is p of x is 1 by 1 plus e raised to minus beta 0 plus beta 1 x. So beta 0 plus beta 1 x, that we are calculating by substituting the values of beta 0, beta 1 and x, that is going to be 481 Putting that in this equation, we'll get 0.44. So threshold is mentioned as 0.5. This value of this sigmoidal curve, that probability is 0.44. So it is less than 0.5. Therefore, the candidate with 60 marks will not be selected. So that is the conclusion for this. Now, what are the advantages for logistic regression? So, logistic regression performs better when the data is linearly separable. Linearly separable means if I'm going to represent the data points in a coordinate system, and if I'm having some data points like this, some are like ones, these are some data points, and some other data points are there, say they are circles. So if these data points can be separated using a linear line, then it is easier to classify. So logistic regression performs when the data is linearly separable. So these kind of data is linearly separable. That means it is easy for logistic regression to work with. It does not require too many computational resources as it is highly interpretable. So while we are going to implement a particular problem using logistic regression, it is not requiring much computational resources. And there is no problem scaling the input features. It does not require tuning. So any number of input features, if it is there in the data set, then also logistic regression will works well. It is easy to implement and train a model using logistic regression. So when you are doing the coding for this logistic regression, it will be easier to train the model and find out or classify it using logistic regression. Now the last advantage is it gives a measure of how relevant a predictor or coefficient size is, and its direction of association is positive or negative. That is already I have said while showing that sigmoidal curve. The probability values are lying between 0 to 1. So if it is 0, we can clearly say this is not happening. If it is 1, it is happening. A particular event is happening. But in between values are giving the probability values, that is the association. So if the probability is some 0.4, we can say that if the threshold is 0.5, then that event is not going to happen. Or suppose 40% chance is there for that particular event to happen. So it is giving a kind of correlation, that is whether an event is happening or not. The correlation to that 40% chance is there for a particular event to happen. Or if the probability value was some 70% and the threshold was 0.5, so we can say that there is 70% chance that this event will happen. So that is it is giving an association. The predictor value is not actually a particular value, but it is giving a correlation. So it decides how relevant a particular predictor is. That is, we are measuring that particular thing. Now here is the summary for linear and logistic regression. What are their differences? So linear regression is used to solve regression problems, and logistic regression is to solve classification problems. And in case of linear regression, the response variable, that is the dependent variable or output variable, it is continuous in nature because we are predicting a numerical value. And in logistic regression, the response variable or the dependent variable is categorical in nature because it is a classification task. Now linear regression helps estimate the dependent variable when there is a change in the independent variable. Now here we are going to calculate the possibility. Just now I have mentioned the possibility for a particular event taking place. It is the probability value. And based on that probability value, we will design the class to which the data point can be assigned. Now linear regression, the model will be a straight line, whereas in logistic regression, it is a sigmoidal curve, which is an S curve. That's all. Thank you.